Hi, this is my homework 5. I updated cross entropy derivative. I finished the code for log likelihood with both class function and class derivative. Sigmoid was already provided by Professor. For softmax, I updated the class function to calculate softmax activation. For 10H, this is my activation function and the derivative function. And also this is for my ReLU function and derivative. For L2 and L1, using definition provided from PowerPoint number 3, I created the function for L2 and derivative for L2, as well as function for L1 and derivative for L1. For dropout, I create a function called dropout mask within the network class that return the dropout mask for hidden layers with the shape corresponding to the respective hidden layer column vector in the form of m/1. And this is my code. So I created an empty list to contain the mask, and this is the dropout percent rate and the retain rate. And this is where I created an empty shell of zeros column vectors for the mask for the hidden layers. And here I randomly put 0 and 1s according to the dropout and the retain rates, and then I return mask. And this function will then be called in backprop under feed forward phase. Oh, actually, it will be called, my bad. It will be called under update mini batch because we want to use the same mask for each mini batch. So if the dropout rate is not 0, the dropout mask function will be called, and then the mask will be used for a feed forward phase in backprop. So let's take a look at my results. Sigmoid quadratic cost. I didn't have to make any change here. Professor has already provided the code, so result are the same. Sigmoid cross entropy. I added the derivative for cross entropy, and my results are the same as Professor. For sigmoid softmax and cross entropy, my results are slightly different toward the end with the training cost and testing cost. However, the accuracy counts remain the same as Professor's results. Same thing happened to sigmoid softmax and log likelihood, where the cost values are slightly different at the end, but you can tell that it's very, very close. It's very close. It's just very minimal difference towards the tail of the cost values. However, the training and testing accuracy count remain the same as Professor's. ReLU softmax cross entropy, I have exactly the same results as Professor does. and so does ReLU softmax and log likelihood, as I think ReLU softmax and its combination works well with log likelihood. H, sigmoid and quadratic. I have the same output as Professor does. However, when 10H is used for input, is used for hidden layer, my results are slightly different with, again, the values of the cost for both training and testing, but very minimal difference. Let's see. Sigmoid quadratic with L2 regularization, I don't have any issue as my results are exactly the same as Professor. And for sigmoid quadratic with L1 regularization, my outputs for cost are for both training and testing are slightly different from Professor, but very minimal difference. However, we have the same accuracy counts. And moving forward, since we're running out of time for when using dropout with rate 0.1, I have very close output like Professor does, actually. And same for L2.